Hey, we're back. All right. So 1.4, we are on page 22, and now we're going to be graphing just the absolute functions. I'll make the piecewise be a second video. And again, this is pretty short. My goal is not to make this too long. I know I ramble, so I do apologize. In the end, you're going to be doing the same thing. I will be providing the answers to this, so I won't ask you to submit your homework. Instead, I'll ask you to submit your notes to OneNote. So you will be submitting page 22 and 23 when you're done with this. And you'll see that tab when you go to your OneNote Chapter 1 folder. All right, so first of all, we need to back up and talk about functions in general. So every function that we're going to graph in Algebra 1, even a linear, has a parent function. So if you think about your parent, I have my mom and dad, and the chances are you look similar to one of them. So the most generic version, like the vanilla ice cream of functions, is known as the parent function, all right? And that's what it says here. Well, it doesn't say that. A parent function is the simplest form of a function with no translations or transformations. So I'll talk down below what a translation or a transformation is. You learned about that in geometry. So again, the plainest, simplest version of an absolute value function is the absolute value of x. And absolute value, just to remind you, is how far a number is from 0. So if I ask you how far, what's the absolute value of 7, what I'm really asking you is how far is 7 from 0. So you'd say the answer 7. Or if I ask you what's the absolute value of negative 10, I'm asking you how many, what's the distance that negative 10 is from 0, and that answer would be 10. So what you learned is when you take the absolute value of a number, the number that's in the bars, that actually just becomes positive because distance is only positive, it's not negative. So what we're going to do is we're going to graph this. We're going to make a table. And this is kind of how we're going to do a lot of these. And I'm just going to pick some random points. So I'm going to pick negative 5, negative 1. They're not random. 0, 1, and 5. So again, if I take the absolute value of negative 5, I'm asking you how far negative 5 is from 0, and it's a distance of 5. So given that x is negative 5, f of x or y is 5. Or given that x is negative 1, when you take the absolute value of negative 1, then y or f of x is 1. The absolute value of 0 is 0, 1 is 1, and 5 is 5. So I'm going to graph the shape. And this is, again, the most basic shape for absolute values. It looks like a V. And because this graph is a 10 by 10, it's actually going to look like this, from corner down to the origin, and the origin back up to the corner. It's not perfectly straight. And again, there are technically arrows because I'm not putting a restriction on the domain. So what's going to happen is we're going to take this parent function and we're going to start putting all these different letters with it. So we're going to move out of the vanilla ice cream and get into the different flavors that you have. So first, a translation is when you take something and you just shift it horizontally or vertically. So if I take this pencil and I move it left or right, or I move it up or down, that's a translation. A transformation is actually when you stretch it out. So if you notice, notice how this paper is in shape or frozen. When I transform it, I'm like zooming in basically, or I'm kind of zooming out. Not kind of, it is basically what it is. So it's like when you enlarge a photo or you might shrink a photo. So that's the best example that I can give there. So the letters that are going to start to happen is you might see a negative, you're going to see an A, you're going to see an H, and you're going to see a K. And you're going to see these letters all the time. All right? So let me just take a look here. So let's talk about what these transformations are going to do. This is the fast way to graph. Again, there is always a longer way to graph, and there would have been a longer way to graph on the linear functions, but you learned that you can quickly graph with B and M. Otherwise, you would have made a table, pick some numbers for X, do the math, and get a Y, and then you would have graphed from the table. So we could do that with an absolute value function. That's what I did here. But I don't want to do all this math, so let's talk about those shortcuts. And everything we're going to graph, these same shortcuts will happen. You're going to have to know the shape, and you're going to have to know what all the other things do. So remember, x is in everything that we graph, and f of x is y. It's all the other numbers that have a job. So first of all, let's talk about what this negative might do. This is so important. I hope you don't skip this video. So a negative might flip it. So what will happen is the shape, instead of being a V, is going to look like this. The shape's just going to flip. A is what we're going to say is it's going to stretch, or it's going to compress. So if you think about a rubber band, you know, if I could hold a rubber band down, I can stretch it, and if I stretch it, I should have a rubber band here. The shape, it looks like it's getting skinnier. And then if I compress something and I mush it down, so imagine I'm taking this and I'm mushing it down, it's going to start to look wider. So you know it's a stretch if this A value is bigger than 1, and it's going to compress if that A value is in between 0 and 1. So first of all, it can never be 1 because this A is actually multiplying these brackets, and if you take 1 times anything, 1 times 3, 1 times 4, 1 times 8, you're just going to get what you're multiplying by. So that's why it's never going to be 1, because then it doesn't change the stretch or compress. The reason why it's only going to be between 0 and 1 and never a negative number is because the negative already has its own job. I hope that makes sense. All right, H. H, I will from here on say, is in the house. So what's the house? The house are these absolute value bars. When we get into the quadratics, the house is going to be parentheses. When we get into radicals, it's going to be a check mark. So there's always a house. And whatever's in here, don't worry about the plus or minus, but the standard form of this equation is minus. What I do is I just take the opposite of H, all right, and then that's going to tell me to move left or right. So move the shape left, move the shape right, but you got to do the opposite first. And then K, you're going to leave K as is, and that's going to tell you to move your shape up or down. Got it? Let's practice. All right, so here we go. There aren't that many to try. So just remember our jobs. This is our flip. I'm going to write this very briefly. This is our stretch and our compress. It just depends what value it is. H, you're going to do the opposite. And then that's going to tell you to go left or right. K will tell you to move your shape up or down. So left or right, that's the horizontal transformation that I told you. And up and down, that's that vertical transformation. So let's take a look. The first thing you should do is just identify your transformations. So this says that parent function that normally would be like this, something like that, my pencil's rolling, right? This V shape. First, it's going to flip. So I just want to mark all of this. There's no A, so it's not going to stretch or compress. That V is actually just going to stay the same size. When you look in the house, I want you to take the opposite of what you see. So I see 2, I want you to take -2. And since it's negative, you have to decide, well, does it make sense to move left or right? And I hope you're thinking in your head the answer is, and I'm sure you all said it, left. And then K is going to move up or down. And since K is a net positive number, I should either move it up or down. And I'm sure you're all thinking, up, Mrs. Slauson, let's go. All right, so what we're going to do is we are going to take these points over here that we just graphed. So it's pretty easy. The more you graph them, the faster it goes. So I'm going to kind of do this in little stages. The more you do this, the faster you'll get. But here are those points. But that one's off. So these are the parent function points. So again, the parent function is just the absolute value of x. So I just remember those. -5, 5, -1, 1, 0, 0, 1, 1, 5, 5. I could pick any points, but this kind of spreads out my shape a little bit more. So the first thing I'm going to do is when you do this is you graph your parent function points. We already identified the transformations. And then what you're going to do is you're going to deal with any flip, stretches, or compresses. So let me write that parent function down again. So -5 and 5, -1 and 1, 0 was 0, 1 is 1, 5 is 5. And I'm not going to put f of x, I'm going to put y. So when you make a flip, a stretch or compress, we're going to graph those points. That's kind of optional, the L. I don't know what happened to the L here. But what happens is you apply any stretch or compress, and you take that negative and that A value and you multiply it by the y value. So since I have a flip, basically what's happening, let me switch colors on you here, is what was up here, and it's 5, is going to have a mirror reflection and come right down here. So it becomes -5. And this flips down to here to -1. Think of that flipping point right along the x-axis. So this one's actually going to stay right where it is. This flips to here, and this flips to here. So you can see what happens graphically. But what happens is you're going to take any a value, any negative, and it changes the y values. So you have your original y, and then you're going to have your new y. So 5 becomes -5, 1 became -1. The 0 stayed where it was, -1 and -5. So if I were to do this first and graph, I wouldn't graph the y value anymore. I graph this set of y values. So there's your -5, -5, -1, -1, 0, 0, 1, -1, and 5, -5. So from there, after you deal with your stretch, your transformation, now we're going to deal with the translations. And I'm going to take these, I don't know how many points, 5 points, and each point is going to go left 2 and up 6. So I got a lot of points here. So again, if you don't want to graph all of them, I'm really just trying to get to you to see some of the points and do more steps at once. But when I'm done, my final color will be in red. So this point is going to go left 2 and up 6. So there's 5, here's 6. If you're using different colors, use different marks. So dots, X's, I don't know, hearts. So this is going to go left 2 and up 6. 1, 2, 3, 4, 5, 6. And this one's going to go left 2 and up 6. And this one will go left 2 and up 6. And this point goes left 2 and up 6. So when you're done, you just had your makeover. You had transformation done. This was the before. And what's in red here is the after. All right, let's try it again. So this time, I'm going to kind of go about it from beginning to end how I want you to approach it. So the parent function is what I look at first. -5 goes with 5, -1 goes with 1, 0 goes with 0, 1, 1, 5, 5. So I'm going to get those on there first. So what I need to do is identify my transformation. So remember, A is that number multiplied right in front. That is a stretch. So what will actually happen is when this V stretches, it's actually going to look a little skinnier. I don't have anything in the house, so it will not move left or right, but I do have a number on the outside, and since it's positive, I will be moving this up 4. So what I like to do first is, I'm not going to even graph these points, right? I know what they look like graphed. They're here. My goal is just to graph the final picture. So the first thing I'm going to do is deal with any stretch or compress or flip. So again, the flip, stretch, or compress, you're going to take, if there's a negative value or whatever it is, and you're going to multiply it by the y values. So I'm going to take all these y values, and because a is 2, there's not a negative, I'm just going to double them all. So 5 becomes 10, 1 becomes 2, 0 doubled is still 0. So what happens is what was -5, 5 has now stretched up to here. And -1, 1 has stretched up to here. You can't see that. 0, 0 is kind of like the anchor. It never stretches or compresses. It allows the stretching because it's like the holding down, and then I stretch from here. And then 1, 1 stretches up to 1, 2, and 5, 5 stretches up to 5, 10. So right now, if I did connect them, you can see that it's definitely skinnier than what's on the other page. And now to complete that transformation, I'm going to take the points and I'm going to move them up 4. So if I move these up 4, I run off the graph paper, so I'm not going to worry about that. I'm just going to take this and go up 4. I'm going to take this one and go up 4. And I'm going to take this one and go up 4. And then I'll just connect my points. And I should have a much skinnier V that has also moved up 4. So let's just do a little quick review of domain, range, and all of this stuff. So remember, you always have to mark your key points. So the final graph, this is left. It's always negative infinity. And it's going down negative infinity. On the right side, since it's going right, that's infinity, and it's going down, so that's negative infinity. My turning point here is negative 2, 6. And I have an x-intercept of negative 8, 0. And I have another x-intercept of 4, 0. So my domain, remember that's smallest x to biggest x. So if I look left to right, because that's what x does, negative infinity to infinity, and I'm going to change it to all real numbers, like as was mentioned in the video. Hint, hint, that might be another question I ask. The range is the smallest y to the biggest y. So my smallest y is negative infinity, and if I work my way up, because y goes up, it's 6. And 6 is part of it. 6 is a point, so you want to include it and put a bracket. Positive, so now I'm going to shade on here. Actually, I have a highlighter. So remember, positive is where y is positive. So this stretch is positive, and what I didn't highlight is negative. So I only need to address the positive, and it starts at negative 8 until I hit 4. And this will have parentheses, because at negative 8, when I look at that y value, again, we're saying where y is positive, even though we're writing the x's. 0 isn't positive, so I don't want to include negative 8, and that's why I don't want to include 4, and that's why I use parentheses. Now, where is it decreasing? Well, this is increasing, and then this whole stretch is decreasing. So it starts the decreasing at negative 2, and it ends the decreasing at infinity. Again, parentheses, and parentheses here, because at negative 2, it's not actually decreasing, it's just resting, so don't include it. Average rate of change, we're going to find a few more points. So if x is negative 6, that's what this means. What's the y value? So that is 2. And if x is 0, what's the y value? I know that's hard to see. That is 4. That's not very good 4. So average rate of change, our y's on top. That's a 4. So I like to do 4 minus 2. That's easier, which is 6. And then, no, it's not. Geez Louise. 2. Not thinking. And then I'll do 0, take away 6, negative 6, which is actually 6. And remember, a rate is always out of 1, so that's 0.33 if you divide it on your calculator. So basically, to get from one point to the next, I'd go up a third over 1, up a third over 1, up a third over 1. All right, next one, end behavior. So let's mark those important points. And then the video is almost done. See, I know it's kind of long because I do babble on and on and on. All right, so this arrow is left, always negative infinity, and it's up. This arrow is infinity, but it's up. And I don't have any x-intercepts. I'll just do my turning point, which is 0, 4. All right, so end behavior. Remember, this is a pain to write, but this is you just setting it up. I haven't even written the answer yet. So I want to look, when I said as x gets bigger and bigger and bigger, that's this side of the graph. What's your y doing? Well, it's infinity. It's getting bigger and bigger. And then I'm going to do it all over again. And you have to write it with the LIM on top, the x to infinity, or negative infinity. And then next to all of that, like on the same line, is the f of x. So as x gets smaller, what are the y's doing? Well, that's infinity. So this whole thing is the answer. This is an all right or all wrong. This time I want to look for increasing. So here it's decreasing, and then this part is increasing. So it starts the increasing at 0. Remember, use the x value, and infinity, use the, or the end, use the infinity, parentheses. Where's it positive? Well, you know, the whole thing is positive. So again, if you don't want to write, you know, from negative infinity to infinity, you may write all real numbers. All right, that's it. So what you're going to do now is you are going to submit your notes from page 22 and 23 to OneNote. You'll see a little bar for that. And then your homework, and I will give you the answers, is, let's see, gosh, I didn't even put an absolute value. Sorry, hold on. Never mind. I'm not looking at the right page. You are going to go to page 26, and I want you to do these 4 graphs. And again, I'm going to have the answers on there, so it's really important that you do it first and then check the answers, all right? You'll find a PDF of the answers. And then we'll pick up 1.4 in the next week, and that covers piecewise functions. All right, that's it.